Now that we have performed the analysis, we have also performed the design of the various sections like tapered sections, then the cold form sections. Now we will go for designing some other important component called the connection. Now the steel connection is very vital, and in any structure the member design is not enough. You need to make sure that your connections are equally strong and stable so that any failure should not happen at those connected joints. Now, in several practical cases, we have seen that the designer are very much focused on the member design, but they have taken the steel connection design very lightly. But the reality is sometimes these connections are very much susceptible to fail because first of all, most of the moment connection experiences huge amount of the moment at that joint, and also most of the connections, say for example, the beam and forces, the shear forces you take. So normally these forces are maximum at the connections. So your connection has to be very much well designed, very much stable, and very much strong enough to take any kind of target design requirement. So stat part we have used for forming the member design, but what about the connection design? Now, as we have come up with the Stat Pro Connect Edition, which is very much well optimized as well as it has got a very good integration with other modules like the RAM connection. Then for concrete design, it is like STAD Advanced Concrete Design. Then for slab design, it's like RAM Concept and so on. So basically within the same UI, you can integrate with other tools for performing the other remaining activities. Now, in this case, we will focus on the connection. This structure has already been designed. Now, before you go for RAM connection design, please make sure that your analysis and design has been properly done, especially the analysis, because without analysis, you won't get any joint forces, and without the joint forces, RAM connection can't fetch any member and forces, which is required as input loads in the connection design. So make sure that your model has gone through the analysis successfully. So in our case, it seems like it's fine. Analysis has been performed successfully. Now let's see if I click on this connection design, what happens. Now the moment I click on the connection design, you can see a window will pop up. Now it will just give you some information like, okay, some material has been used and a few of the considerations for example, this one. Stat steel can be used with connection and also some data for this one like 50 KSI, 36 KSI. Now you might be wondering where this value has been fetched from. Now please remember that these values are not fetched from the design parameter because in this case after you perform the analysis you have entered the design phase, you must have instructed some design parameters. Now within the design parameters, you can also see the parameters like FYLD, FU, and so on. Now these parameters which were instructed within the design parameters are only used for the member design. Please note that. That's all. Now these values are not fetched from those values defined under the design parameters because these values are meant for the connection design only. Now, the question is where this value coming from. Let me take you to this material page. Now you can see in this material page, if you double click, now first of all, you can see like title and all those things. Now there you have something called those yield stress, that is FY, then FU, then other values. Now please remember that this value when you overwrite, the same thing would be updated in the windows that we have shown just now. These values would be taken by the RAM connection for connection design. Please note that. Okay, so in case you, because in RAM connection, the material property would be based on the property that you have defined in this table. Okay, so we are not going to make any changes. Got updated anyway. I can rerun the model. Okay, now this time you can't see the window because the first time when you enter this connection design mode, you can see that window. A very important thing need to mention here. This is something that we have collated from several queries we receive from the user. One of the most common question is like, I am using StatPro. Can I go to this connection design directly? I don't have the license. Now, technically, RAM connection needs the separate license for accessing the complete utility and the workflow. Basically, most of the features are not restricted, most of the important features, but few of the post-processing features, that means you want to generate some drawing, you want to generate some DXF file, but most of the design parts are kept open. Maybe few of the database connection templates are not available, but to give you some overall idea of what exactly you can have if you are not having the RAM connection license but having the STAT license, you can still access RAM connection. But most of the things for the basic connections and all, from my experience, I have noticed that these are all available. Okay, now this is the RAM connection design page, but this is not exactly the application of RAM connection. This is the user interface within StatPro. Just at this page, RAM connection has been integrated. That means the moment you come to this page, you can find all the inputs that are required for connection design. So let's see what type of basic connections we can design here. Okay, now here you have the option like you can choose the type of connection directly by going to this tab, select joint and choose the type of connection you are looking for. For example, I am looking for the beam column flange joint. We call it the BCF. Now, BCF means when the beam is framing into the column flange. Now, if I click on this, you can see all the related BCF joints are shown. Now, you might be wondering that few of the members are not being displayed with the BCF joint, but few of them are displayed with the BCF joint. That means four of them has been identified. Now, please note that there is something you must have to take care of. For example, I'm taking this joint. All the joints are identical, but few of the joints are not identified. Now, let's take these two joint. Now, I will explain you the workflow while I go for the designing this connection. Now, for example, from here you can go to the type of connection design you want. For example, this B is the basic connection, S is the smart connection, G for gusseted connection, and this is the beam to girder connection. Now, here you can select the load cases you have imported from StatPro, load cases or the load envelope. Now I'm just selecting few of the basic one, or also if you want to click on some other envelope, you can drag them like this. Now if you go to the settings, now here you can choose the country code. Now in this case, either you can use the US design code or the Indian design code. Uh, Most of the templates are there, but the US design code has more elaborate and detailed templates. Okay, now for example, in this case, let's select this AISC template. Now in this AISC template, if I choose this basic connection for this selected beam column flange joint, I can select the type of templates from here. Okay, now if you select any other templates, it won't work because the template should be compatible with the existing joint. Means, for example, you are choosing the BCW for the BCF joint, it won't work. It will show that it's not compatible. Okay, so first of all, you need to make sure that the connection template you are choosing should be compatible. Fine. Now, if I scroll down, you can see that for this one, it's called like something called MEP knee. Please note that there are ample number of connection templates. So we will create a separate training content for RAM connection where we will see or discuss on some different types of connections. But in this case, we will only focus on the connection that is relevant to this type of PB structure. So MEP means moment and plate knee that is compatible or relevant with this joint. So if I select this, now you can see there is a small thumbnail that would just give you some preview of the type of connection. So you can have some idea that, okay, this is the connection and whether it is suitable for the existing joint or not. Okay, now you can see this is basic connection. In the basic connection, you have set of templates. Within the set of templates, I mean to say that there are set of different variations, like some set of bolts would be different, so sizes and all. So I will select all of them and so that program can select the best out of them. Just drag it to the right side. Now you can see that BCF connection cannot be created at node 80. But this connection is compatible with this joint. It should have been, but this error message would show like this. Note that this joint has not been identified as BCF. That's the reason the BCF connection could not be established. But the interesting part is these joint and these four joints were identified as the BCF joint. The reason being is that in this model I have already created some settings for these four joints, and that's the reason that could be identified. Now, what is that setting? So go to the analytical modeling, go to this beam tool. Now, please remember this step. You need to add the attribute to the this member. I will tell you why this is important. Now this is, you need to select it as a member type and assign it as a primary beam. Okay, so I have assigned the primary beam specification as an attribute to that slope beam. So in general, this assignment of the attribute is not required for any kind of BCF connections. But in this case, it is required. Now, the reason being that when the beam is having the inclination of somewhat within the range of 15 to 75 degree, then only you must have to define this attribute definition to those slope beams. When the beam is normally flat, that means having the 90 degree of angle to the column, then program can easily understand that okay, it is beam, but as it is having some inclination, so you must have to define and instruct program that okay, treat it like a beam. It will search for all the design rules suitable for the BCF. Now that's the reason as this is a PEB structure and my beam slope is more than 15 degree, I have to assign this attribute definition to that beam. Okay, now this time it should probably work. Now let's select this to joint and okay, must have to rerun the analysis. Okay, now if I choose this two guy like this and same way if I go to the basic connection, go to this MEP knee BCF. Now this time probably it will work. Status call no good. Okay. Okay, now these are the connection that I've already designed for this model previously. but this time I have just designed this set of beams and designed the connection within. So if you double click on that table, let me show once again. Now here you can see this in this table, you can see the status, that is the ratio. Now the good part is in this model you can select n number of connection which falls on the same pattern of the template, and within the selection the design of all those connection would be fired in a single go, just in a fluke. So the ratio would be reported accordingly, and this is the design ratio, demand versus capacity. Now you might be wondering how program has designed it. Where is the application? Now basically the RAM connection algorithm is running at the backdrop. Now for this ratio, if you want to see how the design looks like, and if you want to see the overall design reports and calculation, you must have to double click this. Now you can see this is called the connection pad, and this connection pad is the UI of RAM connection. Now you can launch the RAM connection as a standalone mode also, because RAM connection also exists as a standalone mode. Now this is in this workflow we have used the integrated mode. Now this UI you will get also in the standalone mode. So basically this is the same UI used by the RAM connection. Okay, now this is the joint. Now you must be aware that this kind of joint is quite familiar in the pre-engineered building. Now you can see this is the tapered section of the column, and this is for the slope beam. Now here you have different options. In case you are not happy with the loading, you can go to this load and you can make the changes here. But these loads and all has been pulled from the stat post processing for that particular joint. You can also change the design code from here. And there are a lot of other options where you can just make some changes so that you can design it as per your requirement. For example, in this one, you can see here these are the set of bolts that program has selected, which is the best set of available components within the design criteria. Now you can make the changes. For example, if I go down and here you can see from 3 to 1, immediately it has reduced from 3 to 1. So this is the best design that program has performed for you. Now on top of that, if you want to override that selection, you can make the changes from here. Now here you can make the other changes like this one, the plate alignment. Let's see what are the other different option that I can choose. This is the vertical alignment. You can see the default is the perpendicular, and mostly in this cases this setting or this connection through the plates is quite common. Uh, Even this one, but this is not that common, but this one is very much common, perpendicular to the beam. And here you can also change change the angle. So this angle program has automatically calculated from STAAD modeling, but if you want to overwrite like 45-degree, you can make the changes like this. So let it be like 20.087, which is the actual angle of this structure. And also you can further select the tapered sections if you want some user section or some standard section, like not non-tapered like roll section. You can still choose from this different section database. Uh, this is for the exists opposite connection, but in this case it is not applicable. So we will just go ahead with this set of connection. Now here you can see, like, this is the three-dimensional drawing. Now you can see the drawing representation is very much impressive. It will give you some real life feeling of the entire connection alignment and the layout. Now you can just move around to see if that layout is good enough to exist in your structure. And also you can select this DXF, and if you select this DXF, it will show you the complete sketch of those connection details from different views. You can even save it. If you go to this one, export to DXF, you can simply save it and you can open it in the software like MicroStation or AutoCAD, which can read the DXF file. So basically, you can use it for generating the detailed drawing. And also you can set different types of layers, just like in the AutoCAD or MicroStation, you can set the layers, you can set different kind of layers here. Okay, now the most important and most differentiating feature in RAM connection is the display and the reporting of the result. If you click on this result tab, now let's see. Now, first of all, it will show you all those input information like input loads, load case number, and all basic geometrical consideration. Now, this is the design check. Step by step, it is checking all the important relevant clauses from the selected code, and it will show you the design clause and also the equation number. Okay, so here you can see where it has failed, where it has passed, and also the guiding load cases or the combination. Now, on top of that, if you want to get more insight, like you want to have the idea like, okay, it has been failed, what are the equations involved? You want to know some more in-depth information, then you need to click on this icon, this alpha icon. The moment you click on this, it will generate all the associated formula which is utilized by the program to arrive to this design ratio. Now you can see this result with this formulation is very much elaborate. You can straight away take the printout and submit it in your project report. So the idea is you won't be in the black box like how program has determined those ratio values. You would be provided with all the references and all the relevant formulas. Now, next, let's see some other type of connection. If you want to save the changes, you can may go ahead and click on yes. I'm just canceling it out. Okay, now we will design another type of connection here, that is the connection between these two beams. Now, basically, if I show you in this rendered view, you can see the connection is in between these two tapered beam. Now, essentially, these two beams are to be connected through some proper arrangement of connections. In practice, this type of connection is done through a plate, and also it is known as the beam splice connection. Okay, now please note that in this case also you need to again assign the attribute as a beam to these two members so that a program can identify that okay, you are considering these two slope beam as beam because these two beams are again having some inclination. Okay, now that I have selected these two beams, I can again go to this basic connection and I can scroll down from list of templates in that library. Now just scroll down. Now this connection is compatible with this type of joint. So select this connection, that is the moment end plate BS. You can see beam splice. Now here you can see some quick preview and it looks good for this connection. It is assigning the connection and also it is performing the design. Okay, it has performed the design and looks like the design is no good. Okay, this is the connection design. You can see a small gray colored marking at that joint. That means the connection has been performed. If you double click on this, you can see. So this is the connection between two tapered sections, or rather two tapered beams. Now here you can make different changes, for example, bolt rows. If it is from 3 to 2, you can make the changes. If I want to make it like this, you can just make some changes in that connection layout. So the design ratio is this one, it has failed. And then you can go to the result to see what are the different clauses that are involved declaring this connection as failed. Okay, now we are going to design other type of connection that is in between these two. This is also a very important connection that is at the top. We call it the apex connection. Select these two beams. If you see this 3D rendered view to have some idea, this is the two opposite beams having two opposite slopes meeting at this apex. Go to the same basic connection template. Just scroll down. You can see moment end plate BS apex. Now this connection is compatible with this type of selection. Okay, so this is the ninth. Okay, so this is the apex connection. You can see nicely it has designed this apex connection, and you can see the two opposite slopes of the beam. Okay, you can change the angle from here, and if you want to include some beam stiffener, you can click on this. It will add some additional stiffener at the peak. Okay, so you can get the detailing if you go to this DXF same way as I've explained earlier. So we'll see one more connection here, although there are a lot of different other types of option to perform different set of connections, but I will just cover some of the important connection which are very much relevant to this pre-engineered building. In this session, I am discussing the connection which is mostly relevant to the pre-engineered building. So three of the connections that I have already defined. The last connection that I am going to explain here is the base plate. Now this base plate is not having the regular uniform column. In this case, you are having the tapered column resting on the pedestal connected to the base plate. So that's the specialty in this case. So in this base plate connection, you didn't have to select the member, just straight away select the node. Okay. Now from here you can go to either basic, smart, gusseted and all, but the base plate is available only within the smart connection because this is a kind of smart, or you can say the advanced connection. Okay, now before I go ahead, let me explain you what is the basic difference between the basic connection and smart connection. Now the basic connection is something like basic. Let me open the smart connection first so that you can understand. Okay, now if I launch the smart connection, you can see within that available list, you can see only one option. But if you have seen the connection that I have selected from the basic connection, you must have seen there are long list of the different connections. Now these long lists are nothing but having the different variation within the same templates. For example, one connection is having a plate thickness of 8 mm or maybe some different bolt dimension. That's all. So you are basically defining several set of different information with respect to the dimension, and program is selecting the best combination out of that list. But in the smart connection, You don't have that list. You can see only one option is there. That means it is smart enough to choose the best suited dimension. For example, if it is going to select some plate thickness, then it won't look for, okay, you have the 6 plate, 8 plate, 10 plate that are available within that list. No, that is for the basic connection. In this case, it will select the best suited plate thickness within some practical range, and it will use it for designing. That's the reason it is called smart connection. And also in the smart connection, you have some additional option, like there is something called optimize option. Although the design are mostly selected as an optimize, but still if you want to make some changes and then again if you want to optimize that connection, then you can press on that optimize tab. And a few of the connections are only available within the smart connection. For example, in this case, the base plate. So let's go ahead selecting the base plate. Now the support here is a fixed support, and from this list I need to select the fixed biaxial base plate because it is subjected to the biaxial moment. Drag it to the right hand side. Okay, now this is the base plate, and this portion is the taper section of the column resting on the pedestal through this base plate. Now in this interface, you will have all the different options to control the different setting of the base plate design. Now few of the controlling criteria like the length of the anchor bolt, you can change the head shape, what is the type of anchor, if it is simply headed or if it is having the L or J shape. For example, if I select this anchoring as a J, now immediately you can see these illustrations are updated. Now you can see these are having some bendy shape that is called the J hook. You can also set the type of reinforcement in the anchor reinforcement setting, primary or supplementary. Then the material of the anchor, the embedment depth. If you want to include the correct concrete, then other property like if it is brittle or not, you can set those controlling criteria at this options. Now another important thing is as these anchors are going deep inside the concrete pedestal, so you also have the choice to control the concrete property, specifically the material property. Now here you can set the pedestal option like longitudinal and transversal dimension, thickness, and also the grade of concrete. Now you can select from here and you can choose the grade of the concrete. It's for US. You can go down and you can choose for Indian. It is like M15 or M10, 25, whatever you want, you can choose from here. So I'm selecting the United States. Okay. So you have different options you can choose. You can also choose the country code for designing or for considering this concrete part in this whole base plate design. So by default it's ACI. You can also choose your required design code. Okay, so once it's done, you can go to the result, and similar way you can extract all the key information like the guiding criteria, failure ratios, and so on. Okay, so that's all from my side. This is the normal workflow for this entire pre-engineered building analysis and design, including the modeling. Now, this is a generic example. The pre-engineered building might have some special shapes, special kind of loading. For example, the crane loading. In some pre-engineered building, there are crane loadings. In some pre-engineered building, they have some bracket which is connected inside the columns. where you have some different rails or connectors. So this kind of arrangement also you can use. Instead, we have this option. You can also perform the connection design for these brackets and all. So I'd advise you to go through this entire exercise and practice. And later on, if you find any difficulties or you want more clarification on this, please do not hesitate to contact us or our team. We will be happily looking forward to help you in resolving your concern. Thank you all. See you next time.